发出了进一步要求指导的这样一个请求。当然呢，虽然他的话语非常朴实，但是这个作品也非常有意思。刚才在赛前呢，我也是有幸一睹了他们所设计的智能车的风采。期待待会儿我们的介绍完之后呢，更多的专家和同学们可以去观摩一下。好，接下来呢，我们再次请上下一位的选手，有请国立云林科技大学的同学来我们进行讲解，有请。
Good morning, judges. Our project is hovercraft with Android and FPGA. I'm from Yuntech in Taiwan, and our teacher is Huang Yongguang 老师, and my name is Shen Jiawei, and our team is Xu Gengwei and Ran Weihong. The hovercraft is an air cushion vehicle. It can travel over different surfaces like land, water, mud, or ice. It blows a very large volume of air to make the hovercraft lift, and it can power by one or more motors. On vehicle with several engines, one usually blows the fan, which is responsible for to inflate the skirt. After the skirt is full of air, there will be a high pressure air under the craft and the low pressure ambient air above it, and the difference between this air will produce lift. We use TW019 SoC to be the control center, and use electronic speed controller to control the brushless motor to provide a higher power to lift the hovercraft and a better control, because it is powered by the PWM signal. On the board, there are two lithium batteries, and it can power the electronic speed controller, and we use a regulation to provide 5 volts to TW019 SoC. And the body of the hovercraft is we use 3D printer to produce. Because the hovercraft is too big to the 3D printer, so we divide the 3D model to five parts, and then build them up with screws and with screws. This is our hovercraft. There are 3 motors on our hovercraft. That 2 motors to provide thrust to propel the hovercraft, and this center motor to produce a large volume of air to lift the hovercraft. When the Bluetooth receiver on TW019 SoC receives the control signal from Android device, it will adjust the duty cycle of PWM signal to adjust the motors. And there are a GPS module on the TW019 SoC. It can get the location of the hovercraft and send this location to the Android device. And these 2 modules use UART to communicate with TW019 SoC. This is a screenshot on our Android device. You can see a red tag and a blue point. The red tag is the position of GPS module, and the blue point is the location of the Android device. At that time, I am standing beside our hovercraft. We use App Inventor tool to design our control app. The App Inventor tool is an open source web application. It is just like Scratch. I can design our app by drag and drop these blocks. This is our Android app. There are some sliders and buttons. The sliders can simulate the throttle of the remote controller, and the button fly can make the hovercraft to lift, and flame out will turn off all the engines, and refresh button can refresh the hovercraft's GPS, the hovercraft's latitude and longitude. In order to make control easier, we divide the sliders into 5 parts. The original value of the sliders is from 10 to 60. Now we only use 5 speeds. And this is part of our code, and it is to divide the sliders and send the instruction from Bluetooth. We use Teresic QCs, and in QC this is a Teresic PWM IP. We use that IP to provide the control signal to electronic speed controller, and we use the frequency is 100 Hertz, and the duty cycle will make the motor turn faster or slower. On FPGA we use NIOS2 to be the soft core, and use C to communicate and to compute the right duty cycle of 3 motors with Bluetooth or GPS signal. This is the architecture of our project. The NIOS2 is the center controller. It will communicate with GPS and Bluetooth and the remote controller. Then compute a 3 right duty cycle of the 3 motors, and then send the PWM signal from GPIO to the electronic speed controller, and the speed controller will control the motors. The GPS position value is on the GPS module to D0 nano SoC. Then it will send the latitude and longitude via Bluetooth to the Android device. There are some problems during this project. The first problem is the hovercraft is too heavy to be lifted, so we use a lighter battery. And then the second problem is the current of floating motor is not enough when the 3 motors run at the same time. So we use another battery only for the floating motors, and another battery for everything else. And the last problem is we have not enough time to implement automatic control with camera vision. But now we add a camera on the hovercraft, and it will send a snapshot to the Android device. Okay, thank you.